Hello everyone, very good morning. You are watching my YouTube channel CloudX India. So guys, I'm going to talk about system design basic, which is very important topic of this session. So basically, as a IT person, we have to understand what it is, how does it work, what is the importance of this in IT world. Okay, so let's not wait and see what it is and how does it work. Okay, so take an example. As a programmer, you have designed some code, right? So this code, basically what does it do? It takes some input and give the output, right? So this algorithm you designed, you prepared a code and store onto a particular system, which is your own system. Okay, so take an example of the Google, right? So in Google search engine, you put some information and it give the output. Similar code you have designed here for some business. Okay, and since you designed and you found it better and very useful, so you went into the market and advertise this one, right? You connected with one of person, or you connected with this one of the lady, right? So the beautiful lady. So you explained about your code, what it is, how does it work, right? So this you have given trial to this lady. So what does she did? So she connected your system and used the code over the internet. Okay, so she find the code is very useful for her. Okay, and she advertise or given give reference to one of his her friend, right? And they also connected with your system. They also find with very useful, this program is very useful for their business, right? And the similarly they also give reference or you advertise into the market, right? And day by day your code become very popular. Okay, it's becoming popular. And what happened? So once it becoming popular, right, you are distributing this code to the person and they are ready to pay because this code is saving lots of time for them. Okay. And now you, since you are selling it and people are ready to pay, so you have to take care of so many things, right? You cannot give your system to any of the person, right? You have to provide the services over the internet so that at a time you can reach multiple customer. So when you are going to provide such services over the internet, or you are distributing it among person who is paying to you, right? So they also ask you for the availability of the system. Okay, you have to also make sure that the consistency of the system will availability of the system will be always consistent. It will not go down because the person are people are paying for this. Okay, so take an example. So after some time, right, so your code become popular. Okay. And multiple systems, multiple persons are connected with your system over the internet. Okay. And once this system connected, the current capacity of the system is the utilization of system goes high because numbers of users increased. And since you have to make sure the availability of your code or program, so what did you do? You increase the size of your system, right? So since you have to deliver the services, you have to provide the services to the end user because you are getting money from them, right? So you also ensure to increase the capacity or increase the availability. You have to maintain the availability of your system. So you increase the size of your system. And now, in the next month or after some day, the person or audience become more, right? There are few more person connected or office person connected with you. You sold your program with them as well. Okay. And then what happened? The current capacity of system is not enough to serve the services. What happened? You can make your system bigger again. So you make your system bigger. But what happened? So can you make your system bigger, bigger, bigger? No, there is some capacity limit. But at a time, what happened? You think I can increase more resource to my system so that I can provide the services. And the next month, the audience become more. You increase the capacity, and then audience become more, and you also increase the capacity. But there is a limitation. You cannot go beyond the limitation, right? So there is a limitation of every device. Okay, so you cannot increase beyond the limitation, and this configuration or this method is called the vertical scaling. Limit request goes high, you increase the capacity of your server. Next month, the other audience will come, right? So the increase, the continuous connection are coming and resource are going high, like utilization going high. And based on this, you are increasing the system, but there is a limit. And in the vertical, this system is known as the vertical scaling. And in the vertical scaling, you see a failure. This is the single system where you are from where you are serving the services to the end user. And it's a single point of failure as well. So one, there is a limit. You cannot increase the capacity high. Okay. So there is a limit. And also the problem with this system is the single point of failure. So what happened? So if the request goes high and it become very popular like Google or any other services. So in this situation, what you can do, right? Someone suggested, do not increase the current system capacity. Do not use the vertical scaling model. Use the different model. Use multiple system, right? So the other model is our horizontal model. So in this, what happened? So what you can do, you can create a system, right? You deploy a system as you did earlier, right? Use a load balancer. And once the capacity increase, what happens? So user will connect to the load balancer and load balancer redirect the request to the this particular system. Okay. And once you see the request is increasing here, you can deploy a new system. As soon as you found that request is increasing again, so you can deploy another system, right? Similarly, you can deploy the multiple system based on your requirement, right? So this is the vertical scaling. This is a horizontal scaling. Okay. In the horizontal scaling, what you can do, you can set up parallel system. In the vertical scaling, you can increase the resource of your current system, right? And the vertical scaling is single point of failure. And in the horizontal, you have multiple system, right? And nowadays, as you all aware, right? So there are so many other services are available, right? Which you can use to improve the capacity. Okay. So you can use the auto scaling. What does it do? Basically, it analyze the current uses of your server or your load balancer. Okay. And based on it, it increase and decrease the numbers of server. Okay. So you can do the better capacity planning, right? But it is possible into the horizontal scaling only. Okay. So in the next slide you can see what is difference between horizontal and vertical scaling. Okay. So in the vertical scaling, as you saw, so there is a single system which we are increasing high and high. Okay. So what happens? So this is the single point of failure. It's not using the load balancer. Okay. And into the horizontal scaling, you have seen it is using the load balancer. Okay. So when you are using the load balancer, so it provide you the resilient network, right? So in vertical, single point of failure, right? Because there is a single server. If it goes down, so it will impact to all user. And into the horizontal, it is resilient. Okay. In resilient, basically what happens, so load balancer is the front for each user, and in the backend you can deploy multiple parallel system. Okay. Right, which serve the services. It's an inter-processor call. Basically what happens, so user directly connecting to your vertical scaling server. Okay. So there is no network interference like load balancer plus your server, right? So your user is directly hitting or contacting to the server. Okay. But in horizontal scaling, it's a network procedure call which may be slow. It definitely it's a bit slow than your vertical scaling system. Okay, because in the vertical you is directly connecting to the server, and into the horizontal they are connecting to the load balancer, and load balancer further redirecting request or connecting to the backend server. Data is very consistent into the vertical scaling. Data is very consistent. Why? Because the user directly connecting to the server and server connecting to the backend database, whatever it is. But in horizontal scaling, what happens? So you are connecting to the load balancer and load balancer connecting to the backend server. What if backend server goes down or there is any network disconnectivity between load balancer and backend server? Okay. So in this situation, so there is bit inconsistency you can feel, right? But it is rare. Okay. So next, th- in the vertical scaling, right, you cannot increase the limit of hardware more than the hardware capacity planning. Okay. So there is a limit of hardware, every hardware. But in horizontal, you can scale up multiple robust system, right? Multiple robust system into the backend. There is also limit, right, how many system you can add into your load balancer, but yes, it is more resilient and powerful than vertical scaling. Okay, so guys, that's all. And if you feel like it's a you find it better, right, so please guys comment it, and also share this with your friends, subscribe the channel, and also you can connect me on the Facebook. Thanks guys, thanks once again for watching this video.